Okay, we are almost through the prerequisite chapter. In section 5, we are mainly dealing with solving quadratics. Part of this section is doing it on the calculator, which is something that's not going to be very easily recorded. But we can take a look at the 3 other methods of solving a quadratic. Now, a quadratic has this form: ax squared plus bx plus c equals 0. And if we don't have this form, then either we need to get it in this form or it's not a quadratic. It is a quadratic, however, if your highest power of x is x squared. You can be missing any of these other 2 pieces and it'd still be a quadratic, but if it's a quadratic, it must have an x squared in there, and that be the highest power. Alright, so factoring, completing the square, and the quadratic formula are all algebraic methods to solve quadratics. So let's use the example 2x squared minus 3x equals 2. Okay, so this is a quadratic, I know, because the highest power of x is 2. See, 2 right there. If I'm going to factor that, I'm going to get everything to one side. And I factor out the common thing. There's nothing common. So I'm going to presume that we can factor this. So these 2, their product must give me the 2x squared. It does. And I have a 2 here. And I have a 3 here, which means I need to get factors of 2 such that their sum, when one of them is multiplied by 2, is a 3 or a negative 3. So we're going to have a 2 here and a 1 here, negative, positive, and our quick check, x. Negative 4x gives me my negative 3x. So that's good. So we'll take that away, get that out of the way. Now, we're going to use the 0 property when we're factoring. See, 0 must be on the right-hand side, which means one of these 2 things must be 0. If I had a times b equals 0, you know that either a or b would have to be 0, because anything times 0 is 0. Or they both could be 0. So we're going to say 2x plus 1 equals 0, or x minus 2 equals 0. And then we solve both of those. So we subtract the 1 and divide by 2, get x equals negative a half. And here we add the 2, and we get 2. Alright, so that's by factoring. Now we should get the same answer with either of these, and you're going to do factoring as your default. Factoring's the fastest. Completing the square and quadratic formula take longer and are more prone to mistakes. We're going to tend to like quadratic formula over completing the square, but we will need to know how to complete the square to do other types of problems. So we're going to start the same way. Now, a difference with completing the square is I really don't need to have the 2 on the other side. I don't need the 0 property. But what I do need is there to be a 1 in front of the x squared. So no matter how ugly it is, I need to factor out that 2, which basically means I divide all of these terms by 2. And I'm just going to leave a space here. Now, at this point, you probably could go ahead and divide by 2 to the other side. I'm not going to do that because in other problems later, you won't be able to do that. So we're just going to leave it there for now. I want this to be a perfect square trinomial. And in order to get that, I'm going to look at this term, and I am going to divide it by 2. So basically multiply the denominator and then square it. And in the end, I'll always get a positive number, and I'm going to add that to here. Now, I've added it inside parentheses, and this is important why I didn't do this too, because later in the year we won't be able to get rid of this thing. I didn't actually add a 9/16. I actually added twice that. So I'll multiply that by 2 just to see what I actually added there. And I actually added 9/8. Alright, so I added 9/8. If I add 9/8 to this side, I must also add it to this side. So there's my 9/8. And I'll erase this other stuff. Alright, so now I can go ahead and factor this. So I will. Well, wait. How do I know? And I'm going to add this in a minute. How do I know it's 3/4? Well, earlier when I completed the square, I had the 3/4 before I squared it. And when we get this number, we multiply these two together. So I just square rooted it to go back to what it was. And I'm going to go ahead and add this 9/8 to that 2, which means I need a common denominator. Its denominator is currently a 1. So multiply that by 8. And we get 25/8. And you can see why, if we can factor, we're going to want to do that. Then we have 2x minus 3/4 squared. We have 25/8. And then we'll go ahead and divide everything by 2. So we get 25/16. And now I see I have a square here. So what we're going to do is we're going to go ahead and take the square root. And when we take the square root, we need to remember we get two solutions. We get a positive one and a negative one. But that square rooting undoes the root. Now I can add the 3/4. 8/4. Add the 3/4 and get negative 2/4. And this reduces to 2. And this reduces to negative 1/2, which is the same thing we had there. But look at all these fractions and things. We'll do more with completing the square, but a lot of room for error there. But we should get the same thing as if we were factoring. Now, quadratic formula, I'm going to go ahead and erase this other stuff so that we can take a look at the quadratic formula a little bit more closely. The quadratic formula is definitely, for solving quadratics, better than completing the square in most circumstances. But what we're going to do is we're going to have, and you need to memorize this, x, or whatever our variable is, if it's a f or a d or c, whatever, it doesn't matter, but we'll use x because that's what we have right here. See, x, if this were a y, it'd be a y right here, equals negative b. So that's referring to this constant right here, negative b, so I switch its sign, plus or minus. So remember, when we take a square root, we have two answers, so that's why that's there. B squared minus 4 times a times c. And a is this, and c is this. So this is a, this is b, and this 2, well, it needs to get to the other side. So it's a negative 2, so c. All over twice a. So I'm going to just put in these numbers. Negative b is going to be 3 plus or minus square root b squared. So negative 3 squared is 9 minus 4. Now this is where, especially if there's negatives involved, a lot of mistakes happen. Just write it out. It takes only a few seconds. I have a negative 2 there, so this should become a positive thing. All over 2a. So we don't want to forget that. Twice a is 4. So 3 plus or minus square root 9 plus, because negative 4 times 2 is negative 8 times negative 2 is 16, all over 4. And then we have 3 plus or minus root 25 all over 4. And at this point, if we can simplify, we do, and we can. So we have 3 plus the square root of 25 is 5 over 4, or 3 minus the square root of 25, which is 5. So this is 8 over 4, which is 2. And this is negative 2. Did I make a mistake somewhere? Yes. This should not be a 4. That should be a 4. A 2. It should be a 4. See, 4. Miscopied. Negative 2 over 4, which is negative 1/2. And I should get the same thing as I did before. And I did. So quadratic formula. This should be memorized already. If it is not, make it happen. Alright, so one more type, and that's the fourth type, using roots. And we use roots when we're doing completing the square, but this would happen if I had something like x plus 5 squared equals 16. I can, of course, expand this out, subtract the 16, and use factoring. That is an option, but it is way faster if I recognize, gosh, I could just take this square root. And when I take this square root, I get x plus 5 equals -4. Remember, we get two answers when we do this. X plus 5 equals 4. Subtract the 5. Subtract the 5. And then we have both our answers. So we can use taking a root in instances where we do have perfect squares on both sides. Alright, so I have no specific directions on these examples, so we're going to want to use the easiest method. So I have a squared here and a 16 here. Those are perfect squares. So the fastest method is just to take the square root. And remember that a square root undoes a square, and I also have, whenever I use a square root as a part of solving, I need to account for that there's two answers. So this could be -4, or it could be +4. And now I add the 1, add the 1, and divide by 2. Add the 1, divide by 2. And just to emphasize, we don't have to do it this way. I'll go ahead and do it the other way. I can expand that out, and if I do, I get 2x minus 1, 2x minus 1 equals 16. Multiply, but this is a lot of work. See, I'm multiplying each of these, plus 1. And combine our like terms. Get the 16 on the other side. Gosh, this is really nasty. And although this is factorable, we always start with the factors closest together. And I have a negative here, so I'm thinking this is negative. If this, when we're factoring, if this is a negative, that means that our signs are opposite. And now one of these is 0, or both of them. That should be 2x. And I saw both of those. And we get the same thing. And you can see by far faster to just take the root right there. Alright, this one. Let's be realistic. Let's think about how we would actually do this. Our first choice is to factor, if we can. Our next choice will be to use quadratic. Our last choice will be to complete the square, and we'll just use that when it looks like it's convenient to do so. So let's try factoring. I don't know if this will factor. Let's try. I have a 5 here, so I'm thinking a 3 right here. That gives me 6. But I need a positive side, so plus and minus. Minus 1, -3. So let's do our quick check. Negative x, 6x, 5x. Good. Okay, so we're good. So 2x minus 1 equals 0, or x plus 3 equals 0, x equals a half, or x equals -3. Alright, now before going on from this, I want to talk about, well, what we are actually finding. What we're finding, you can call them the zeros, or you could call them the roots. And what happens when we have, and I have a graph here, and it doesn't necessarily have to be a quadratic to do this, it could be anything. So if I had something like this, that would probably be a degree 3. But what we're finding are these. This point, this point. Now in the case of a trinomial, there will be possibly 3 of them. But we're finding these, and why did I put a z here? That's not a z, that's an x. We're finding the x-intercepts. These are x-intercepts. And x-intercepts happen when y equals 0. So we're finding these. So in a quadratic which is degree 2, we might have a situation like this. We're finding these two things. I mean, we could have a situation like this where it goes up. We're finding these two things, and it doesn't have to be split across the axis. It could be touching the axis. Maybe we just have one. It could be touching just once. Anyways, that's what we're finding. We're finding the x-intercepts, these zeros, these things on the x-axis where the graph hits it. Alright, going on. We are going to solve these two by factoring. That's why I wrote factor down here, to remind myself. Factor these. Alright, so we need to get everything to one side. That's the first thing. This over here. So we add that. We factor. X, that gives me that. And this is a negative 8. This is a positive 15, which tells me that both the signs are the same, and since this one's a negative, they're both negative. 5 and 3. So x minus 5 equals 0. X minus 3 equals 0. X equals 5. X equals 3. Alright, this one. Now when we look at this and we think, well, it's factored already, there's not even a squared. But this is not 0. Not 0. So I need to get everything to one side. I need it in this form. ax squared plus bx plus c equals 0. And this is not in the right form. So I'm going to go ahead and distribute this. Gosh, we're awfully close. Subtract the 20. And now I'll factor. I'll do it down here. Always factor out the common thing. I know I'm jumping right to this, but we always need to check that. That's the only way to get my 3x. I have an 11 here. If we do a 5 right here, we get a 15, and a 4 right here, we get a difference of those. That'll work. That's good. This is negative. So since that's negative, I know these are opposite sides. This is positive, so I know the bigger number needs to be positive. So this one positive, this one negative. And when I do my quick check, negative 4x, 15x, I combine those, I get my 11. I don't know why students don't check their factoring. It's pretty easy. It only takes a couple seconds. X equals 4/3, x equals negative 5. And we're good. Alright, let's see. Do I have another factoring? Roots. I say roots. Use roots on this. Okay. These are not very nice ones to do roots with, but it's still faster. Now, I can't take a square root right away here because of this 2. So I'm going to divide both sides by 2. Alright, and to undo a square root, or a square, I take a square root. So x minus 5 equals root 17/2, or x minus 5 equals negative root 17/2, whatever that is. Then we add the 5 in both cases. Now, we need to rationalize. This is a negative right there. So I'm going to get root 34 over 2 plus 5. And rationalize this one. X equals negative root 34 over 2 plus 5. Now we could put these together if I wanted. I could get a common denominator. And go ahead and write that like this. But this is not a necessary step. Really, same thing, 10 over 2. And then we get 10 minus root 34 over 2. And that's this one. So, still faster than if I had expanded this. And there tends to be expanding mistakes when there is a number there. Let's go ahead and do this one with the quadratic formula. Now, if I were doing the quadratic formula on this one, I need a 0 right here, and I need to expand this. So I'm going to go ahead. When I expand this, I'm going to expand this part first. This times both of those. This times both of those. Combine like terms. Distribute the 2. Subtract the 17. Three, 33. Alright, so A, B is a negative 20, and C. So when I go into my quadratic formula, x equals negative b plus or minus square root b squared, that's 400, minus 4 times A times C. And I'm not going to finish this out, I'm just going to write it. 2A is 4. And then we would simplify that. Well, maybe I'll do this. So this is an 8. The square root's not going to be nice. Well, let's do this. 66 times 4. 264. And then I have 400 minus that 264. Oh, nope, plus. See? Got to keep track of our signs. So 664. So showing the next step, x equals 20 plus or minus square root 664 all over 4. Now this looks different than the other one, but remember when we did radicals we need to simplify them. So I take the 664, I'll divide it by 2. And divide it by 2 again. Doing everything by hand because I don't have a calculator handy. 166. Divide it by 2 again. Hopefully I'm not making a mistake on my division. I think I am. I think I did. Oh well. You can find my mistake at a different time. So, equals 30 plus or minus 2 squared times, this did not work out. It should have worked out, but something happened. 166. I don't think that's divisible by anything. Times all over 4. And the square root of 2 squared is... So I obviously made an error somewhere here. I don't know where. And these cancel. I can divide those all by 2. Oh, this is a 30? No, that's a 20. That's a 20. So there's one error. That was a 20. So divide those by 2. 10 plus or minus root 166 over 2. Okay. Going on. I don't know where my mistake was, but it is somewhere in there. Oh, we need to do this other problem. Alright, so the square root thing, obviously the better way. So we'll divide by 4. And now we'll take the square root. Maybe I did something wrong in my rationalizing over there. That's possible. So we take a square root, x plus 1. 3 square root of 9 is 3 over root 2. Negative. Or the positive version. I'll rationalize. So this should be root 2 over 2. And 3 root 2 over 2 will be the same. And subtract the 1. That is annoying me. And subtract the 1. That's on the other side. It's annoying me. I don't know what I did wrong over here. And we could get a common denominator and combine these. So it could be plus or minus 3 root 2 over 2 minus 2. Like that, if we combine them. I don't know. Okay, this one says solve by completing the square. When we complete the square, we'll keep this and we actually get the extra thing to the other side. And completing the square is very ugly. There is no number in front of this, so that makes that, that's a little bit better. So we don't have to worry about that. So we're going to half this thing and square it. So half of 5 and then square it. Alright, so we're going to do x squared plus 5x plus 25 fourths equals 9 plus 25 fourths. Whatever I add to one side, I must add to the other side. Alright, now when I factor this, I should get x plus 5 halves squared, whatever I divided that by, equals, and I need a common denominator here, so 4 and then we take the square root. So x plus 5 halves. That will be plus or minus because I have 2 of them. And then we subtract the 5 halves. So x equals negative 5 plus or minus root 61. All of that's over 2. I could combine them because they had the same denominator. Alright, this next one. Let's get everything to one side. I shouldn't have done that. I should have left the 4 over there, so I will. And go back, go round and round. Alright, so this one's actually not that bad to do completing the square, because half of 6 is 3, square it, and 9. So I add 9 to this side, which means I add 9 to the other side. So I get 13 equals, and then I can factor that, x plus 3, real easy. And then I take the square root. And I get 2 answers when I do that, plus or minus. Subtract the 3, so negative 3 plus or minus root 13 equals x. Not that bad. Alright, this one, also completing the square. Oh, look at all this stuff. Freak out. No, just simplify it. So I can distribute that negative x. And I'll start by combining some like terms. So those cancel each other out. And then I have 2x plus 3. Get everything to one side. Well, we're doing this by completing the square, but I'll still get everything to one side. Just force the habit because actually quadratic formula is much easier. So 3x squared minus 9x minus 10 equals 0. And we could use quadratic formula this. This would be a. This with the negative would be b. And that would be c, the negative 10. But we'll do completing the square because that's what my directions say. We'll get the 10 to the other side. Now, we must have a 1 right here, so we need to factor out the 3. Now we half this and square it, so half of that and square it is 9 fourths. Alright, now we factor that. Oh, not yet. If I add something here, I have to add something here. and is 3 times this amount because of that 3 out there, so plus 27 fourths. Minus 3 halves. Let's get this into the same thing, so 67 fourths. And now we divide by 3. And square root. So I'm going up here now. Quadratic would have been definitely the better option. Square root of 12 to root 3. Plus or minus. I need to rationalize that. So 67 times 3. 18. That's divisible by 3. Oh yeah, of course it is. Plus or minus root 201 over, this is going to be 6. And then we add that 3 halves. So x equals 3 halves plus or minus root 201 over 6. And if we combine these, get a common denominator. Okay, and I am quickly going to see what my answer key says that should be, because that looks odd to me. Yes, that is not what the answer key has. Let's see. Unless I miscopied my problem. Alright, so we're going to do that again. The answer should be 4 plus or minus root 46 over 3. So let's see what went wrong. Let's go back over it. So combined like terms, distributed. So those went away. And then got everything to one side. Yes. And then that looks fine. 3x squared minus 9x. Added the 10. Factored out a 3. And square that, so 9/4, so I added 9/4 here, but 3 times that amount, so plus 27/4. Get a common denominator, 67/4. Divide by 3. Maybe I'm doing something really wrong here. Alright. Let's just do it again. What was that? Negative x plus 3. Alright. 3x squared, 6x minus 7 equals x squared plus 3x minus x squared minus x plus 3. Those do cancel. I didn't copy it right. X squared, subtract that. Oh, that should be a 2. There's my error. 2. I'm a sloppy face. So that should be minus 8x. That will change things significantly. Alright, so now when we factor out the 3, alright, so it took me forever to find that mistake. Factor out the 3. This is why you need to be neat in math. Add that 10. So this is all wrong. Now, half that. See, I just doubled that to half it. Which I'll go ahead and reduce this to 4, divide those by 2. Square it, so 16/9. If I add 16/9 here, triple it, so that's 18/48. So 48/9, so plus 48/9. And then let's get a common denominator, 90. Well, this is not looking much better. May my mental math skills not fail me. 3. Factor this. Now divide by 3. This is horrible. Let's see here. Can I reduce this? Possibly. Not 2. What am I thinking? 4. Yes. So let's reduce that. There's the 46. Yay. Divided that by 3. So I reduce this by dividing by 3. And now we take the square root. Yay, this looks way better. And the square root of 9 is 3. And then we get this. So then we will, that's plus or minus. We add that 4. And since they have the same denominator, that works. So that's good. Alright, that took forever. Alright, quadratic. Let's see. Since that took forever, I'll probably just do this one. I'll forget about that one. This is A, B, and C. So x equals negative b plus or minus square root b squared. So negative 3 squared, which by the way, negative 3 squared, that's 9. So 9 minus 4 times a times c, all over 2a, so that's a 4. And that's going to be a 1. The square root of 1. So if we can simplify this, we do. We don't just leave it like that. If I can simplify that, I do it. So 3 plus or minus 1 over 4. So I could have x equals, subtract the 1, or add the 1, and then reduce these. So a half and 1. Alright, that's with quadratic. Alright, absolute value, really quick. This is at the end of P5. Absolute value, using this as an example, is distance from 0. So here's 0. A distance of 0, of 6, because absolute value of x being 6. I could be here at 6, or I could be at negative 6. So when I solve this, I could say x equals negative 6, or x could be 6. Because either way, if I did the absolute value of negative 6, I get 6. If I do the absolute value of 6, I get 6. So I have two possibilities. So when I'm solving, I need to account for that. So I get the absolute value completely alone first. Alright, this one's alone. And then I split it into two things. X plus 9 could equal negative 4, or x plus 9 could equal positive 4. And then I solve both of these. So negative 13, or x equals, subtract. Now some students just put a 13 here and say negative 13 or 13 because they're out. No, because when I subtract the 9 here, I actually get a 5, not a 13. Okay, this one, again, get the absolute value alone. So we're going to add the 7. Divide by 3. See, you can't distribute into that right there. And then 2x minus 5 equals, I don't want that in absolute value. And 2x minus 5 equals 6. Split it into two different things. So 2x equals, add the 5, divide by 2. Add the 5, see 11, divide by 2. See, it's not just a simple matter of it being opposite in sign. So we split it into two different things. This one is a little bit tricky, but it's the same process. get the absolute value part alone. It is. So it could be negative x, or it could be positive x. Solve for x. Add that x, get the x's to one side. Add that x. And then get the 5 on the other side. In this case, we see that we just get the same number. It's the same thing. But these you might, for now, do on your calculator. Alright, sorry for the mistake earlier, and probably I had another one, but oh well.